The surface of the moon is finely ground aluminosilicate material. So we are working on alkali activating that material to convert it to a geopolymer, which would have properties like hardened concrete that we know and could sustain the life and shelters and infrastructure on the moon.
In order to be able to use the lunar concrete that we're working on formulating, it also needs to be activated with some heat, and there are a number of different ways that can be done. We've chosen to use microwave because just like your microwave oven in the kitchen, it heats throughout the material, not just from the surface in. And that's a very similar effect that we need when curing the lunar regolith concrete. Applications that we can use on the moon to help prepare the materials before we actually put them into the lunar concrete. For instance, helping to remove some of the sharp edges that you find on lunar regolith. And those are other things that we are exploring right now. What I love about the challenge of 3D printing lunar concrete on the moon is that it's a systems challenge. I've got to work with my colleague Aleksandra, who is an expert on the lunar concretes. I'm a system engineer, an electrical engineer by training. I help build the systems that will help us to do that 3D printing. We also need to explore the type of environment that it's going to be printed in. So we need to build temporary structures to be able to provide the atmosphere and the appropriate curing environment for the concrete. That also allows us to reuse any sort of activator that we'll find. These are the kinds of challenges that we're exploring. It's a real systems challenge, and we look forward to being able to implement 3D concrete printing on the moon.